Rain can make the same gray pavement look almost black within seconds. The material has not changed color, and the water itself is nearly transparent. The change comes from where the incoming light goes and how much of it returns toward your eyes. At human scale, asphalt looks flat. Under magnification, it is a jagged landscape of stones, binder, pores, and tiny air gaps. Each small face points in a different direction, so incoming daylight meets thousands of different angles. On the dry surface, light repeatedly meets boundaries between air and mineral. Many rays bounce from exposed grains or scatter inside shallow pores and return upward. This diffuse reflection makes the surface look relatively pale from many viewing positions. Rainwater flows into the low points and connects isolated droplets into a film. The outer surface becomes smoother, while the air gaps close to the top are replaced by water. That replacement changes the optical boundary seen by each incoming ray. Water has a different refractive index from air. When a ray crosses from air into the water film, it changes direction. Instead of meeting a sharp air-to-stone boundary and bouncing back quickly, more light is guided toward the pavement below. Water is optically closer to many pavement minerals than air is. The smaller mismatch reduces reflection at the first contact. More light enters the dark, irregular material, where it travels farther, strikes more grains, and has more chances to be absorbed. The pavement appears dark because your eye receives less diffuse light from it. The water did not paint the road black. It created a smoother entrance that allows more of the illumination to leave the easy return path and disappear into the surface. A wet road can look dark from one direction and mirror-like from another. The smooth water surface produces a stronger directional reflection. If your eye is near that reflected direction, you may see the bright sky or a lamp instead of darkness. Headlights that once scattered broadly from dry roughness can be redirected by the water film. Some of their light travels away from the driver, while another narrow portion creates intense glare at particular angles. This is why wet road markings can become harder to see. A puddle thick enough to hide the texture beneath behaves more like a continuous mirror. Damp asphalt still reveals its rough structure, but the filled pores and thin film reduce its diffuse return. The amount and shape of water determine which effect dominates. The same idea applies to concrete, stone, brick, soil, and fabric. Their dry pores contain air and scatter light strongly. Replacing that air with water often reduces near-surface scattering, so the material looks darker and its colors appear more saturated. As water evaporates, high points and warmer zones dry first. Pale islands spread through the dark surface. The patchwork is a map of surface height, drainage, airflow, temperature, and the changing thickness of the remaining water film. Look at a sheltered patch beside a wet sidewalk. The material and illumination are nearly the same, yet the wet region returns less diffuse light. Then move to a low angle. The wet side may suddenly flash with a reflection from the sky. Wet pavement looks darker because transparent water changes the path, not the color, of light. It suppresses the rough surface's easy backward scattering, sends more light into the absorbing material, and reserves its strongest reflection for a narrower set of angles.